Mercury is the nearest planet to the Sun in the solar system. Every image or video of Mercury is taken by the Messenger probe. We go through Mercury's orbit and spin, as well as the planet's physical attributes, weather on its surface, and magnetic field and magnetosphere. You will learn practically everything you could ever want to know about this tiny but interesting planet if you follow along with me in this video. Subscribe to AWZ and let us know if you enjoy our video. Mercury is the closest planet to the Sun, so I'm sure you picture it as a huge rock floating in space when you think about its physical attributes. You wouldn't be too far off, but it's far more fascinating than you may imagine. For instance, I do consider our moon when I gaze at Mercury. However, the visual attraction of Mercury is higher than that of the moon. View it in its natural hue. The fact that it actually has a color is the first thing I notice. There are more than just various tones of gray. And furthermore, for instance, did you know that Mercury is made up of roughly 30% silicate and 70% metallic components? More metallic than rocky is more accurate. Because of this, Mercury has the second highest density in the solar system with 5.427 grams per centimeter cubed, just behind Earth, whose density is 5.515 grams per centimeter cubed. Mercury would have almost the same gravitational pull as Earth's surface if it were the same size as our planet. However, due to its size, it only has a surface gravity of 3.7 meters per second squared. Its gravity might resemble something like this when compared to Earth's. As a result, Mercury's surface gravity is only somewhat lower than that of Mars, which, given that Mars is a considerably larger planet, merely goes to show how dense Mercury is. One more comparison of Ganymede and Titan against Mercury is what I want to show you before we finish talking about Mercury's size. Now, Titan is Saturn's largest moon and the second largest moon in the solar system, while Ganymede is Jupiter's largest moon and the largest moon in the solar system. As you can see, these two enormous moons are larger than Mercury, although having far smaller masses. You may observe that Mercury's surface resembles our moon if you look at it closely. As evidence that it has been geologically dormant for billions of years, it has large mare-like plains and significant cratering. But given the presence of numerous tiny ridges that extend out to a distance of several hundred kilometers on Mercury's surface, it is clear that it was once geologically active. These are thought to have formed as Mercury's crust consolidated and the core and mantle cooled and shrank over time. And one of Mercury's most notable features is this enormous crater on its surface known as Caloris Basin, which has a diameter of 1,550 kilometers. The impact that formed Caloris Basin was so strong that it sparked lava flows and left a concentric ring around the impact crater that was almost 2 kilometers tall. The odd terrain, a sizable area of very hilly terrain, is located at the antipode of Caloris Basin. It is clear why this area was given its moniker when compared to the rest of Mercury. What is life like on Mercury's surface, then? Well, to begin with, the surface temperature varies greatly everywhere. Between minus 173 and more than 400 degrees Celsius are possible. However, because there is no atmosphere to trap the heat, it never gets warmer than -93 degrees near the poles. This indicates that there is a sizable difference between the equator and the poles, but we'll return to its orbit and rotation in a moment. On average, temperatures on the planet's dark side are -163 degrees Celsius, while the subsolar point reaches roughly 400 degrees. Mercury is too hot and small for its gravity to hold onto much of an atmosphere for very long, thus it loses all of the heat it receives from the sun, which is why the dark side of the planet is so much colder than the side facing it. Exosphere, a volume that surrounds the planet and resembles an extremely thin atmospheric layer, does exist on Mercury, though. Exosphere molecules are gravitationally connected to a planet, yet because of the exosphere's low density, it cannot function like a gas because the molecules do not collide. Certain atoms in the exosphere are torn away when solar wind strikes the Earth, leaving behind a trail of atoms that travel into space. Every planet has what we refer to as its tail to some degree. The exosphere on Earth does exist, although it only extends 600 kilometers above the planet's surface. Actually, it's where the atmosphere and space collide. Now, this exosphere is by no means steady in the case of Mercury. Atoms come from a multitude of sources and are constantly replenished and lost. The presence of water ice in the craters at Mercury's North Pole has been verified by NASA. Another feature that Mercury possesses that Mars does not is a true magnetosphere, or magnetic field, completely around the planet. Despite being just 1.1% as powerful as Earth's, it is nevertheless powerful enough to redirect much of the solar wind around the planet. We'll now discuss one of Mercury's characteristics that I believe to be most intriguing: its rotation and orbit. With a range from 46 million to 70 million kilometers from the Sun, Mercury has the most eccentric orbits of all the planets. Now, I realize that this is difficult to imagine, but please stick with me. Mercury's orbit around the Sun takes around 88 days on Earth to complete. A 3-to-2 spin orbit resonance of the planet's axis rotation is also present. This indicates that for every 2 times it orbits the Sun, it rotates 3 times around its axis. Because of this 3:2 orbital resonance, it appears that one day on Mercury, measured from dawn to sunrise, or what is known as a solar day, is equivalent to 2 Mercurian years, even though it takes Mercury around 59 Earth days to revolve once, which is what we refer to as a sidereal day. This is what it would seem like to be standing on Mercury. The Sun would rise quite quickly, slowing down and even appearing to be moving backwards as midday drew near before continuing on once again until dusk. As you can see, it took an entire year, proving that a night on Mercury takes an equivalent amount of time. For Earth days before perihelion, the speed at which Mercury moves in its orbit reaches the speed at which it rotates, causing the Sun to begin moving backwards in the sky. The apparent motion of the Sun remains unchanged at this point. A person standing on Mercury would see the Sun moving backwards because at perihelion, Mercury's orbital speed is faster than its rotational speed. The Sun's regular motion restarts 4 days after perihelion. When viewed from Mercury's top down, this is even more obvious. The Sun appears to stop and start again twice a day on one of its poles. Mercury's orbit is also 7 degrees inclined to the plane of Earth's orbit, which is worth noting. Due of this, we are only able to observe Mercury transiting in front of the Sun when it is directly above of Earth and the Sun. This only occurs roughly once every 7 Earth years due to the 7-degree inclination of its orbit. The last aspect of Mercury's rotation that we'll talk about is that its axial tilt is nearly zero, with the best observed figure being as low as 0.027 degrees. The diameter of Jupiter is 3.1 degrees, making this even smaller. I hope you learned something new about Mercury today and that you now find it to be more fascinating than you did before watching this video. Thanks for watching, and I hope to see you again soon.